Guys, confirm if I'm audible. Good evening. Sorry for the slight delay, guys. Okay, so I hope I'm audible. Good evening. Okay, guys. So let's just start with our day 5. And today I'm going to tell you how to make a rack pipeline. So let's just start. I hope my voice is not echoing for you. Thank you so much, Aniruddha. Thank you. Okay, guys. So let's just start. Today we are going to explore a beginner friendly guide to RAG models. Thank you so much, guys. So, first of all, what is this RAG? ये RAG क्या है? So, guys, RAG just means retrieval augmented generation. So, let me explain you first and then we will come on this slide again. So, what happened back then was when we asked the model about something going recently, like, hey, tell me score of today's cricket match, it would use to say, I apologize, I do not have access of the real time information. My knowledge is based on what I was trained on, which goes up to August 2023. Thank you so much, guys, for your warm wishes. Let's now get into studying. Okay, so rag back then used to reply this. I hope you remember the times when we used to chat with ChatGPT and it replied this when it didn't know about the current scenario going on. So that is what I have written here. In traditional LLMs, the model generate responses based solely on the data it was trained on, which may not include the most current information or specific details required for certain tasks. So I hope you guys remember that time as well. But now, as you guys are able to see, when you are asking some latest information about it, latest information from it, like I have asked it what is the recent updates on flood crisis in Punjab, and it has given me everything regarding it. So what has changed now? The limitation of training part. Earlier we just trained the model and it was ready to go, but it was not enough because information keeps adding, the world keeps updating. So that is why the models have updated themselves with the help of RAG. RAG addresses this limitation by incorporating a retrieval mechanism that allows the model to access external database or documents in real time. What is meant by this is earlier the models only knew the data they were trained on. They were not knowing anything except that. But now, because of RAG, these model can access the external databases. They can access the external documents which are available on YouTube, the Google, etc. Okay, so they can access documents from there, read from there, and can reply you based on that. So that is what RAG is. RAG means retrieving the useful information from sources like internet or something else. Augmented means adding it to the AI's knowledge. AI was pre-trained based on some knowledge, but now we are adding some extra knowledge to it, right? With the help of the documents available. And generate means now they are able to create a better response. Retrieval, augmented generation, generating with the help of context other than what is stored inside the model, other than the training data. And from where it is retrieving those contexts, from databases, from, you know, sources on the web, something like that. So I hope you guys understood till here. Just write yes, and then we will move on. Don't miss the attendance, guys. I'm telling you, for each day, it's important to fill all 7 days form, and then only you are going to get the certificate. Just write yes if you guys understood. Okay. So Sheikh has written yes, then we yes. Okay, Swati, yes. Now you guys know what recently is happening. RAG is being used all over. So, what is RAG? I have told you RAG is a method to add extra information to the model other than what it has been trained on. But is RAG the only way? I will say no. So, another way to make your model smarter is fine tuning the model. Now, what is fine tuning? I will explain you with the help of an analogy here. Let's say there's a doctor. Okay, there's a generalist doctor. He has just completed his first degree and he has now become a generalist doctor. But now, for becoming a specialist doctor, right, specialist heart doctor, let's say, he has to train, right? He has to train himself and learn all those like heart related terms and all those chores for the heart. Now the doctor has to go through a specialization program to become an expert in detecting heart diseases and in curing heart diseases. Earlier, the doctor was just a generalist. Now it has become a specialist on one particular type of thing, right? And what is that particular thing here? Heart doctor, heart specialist, heart surgeon, whatever they say. Okay, so the model has become fine tuned. Why I am saying the model is fine tuned? Because the base LLM has become trained on one particular data set. It has become the master of one particular topic. It was a generalist earlier. It used to reply anything I would ask. But now it has become a specialist in one thing. It can reply based on the data I have trained it on, right? So that is what fine tuning is. Fine tuning permanently updates the LLM's internal knowledge, right, by providing new data set. Now the doctor will remember more of his heart surgery, right? He will remember less of what was taught in the generalist degree, right? The things which are being taught here now in the specialist program will overwrite what was told earlier because these are more specialized, right? So you use this fine tuning for like massive data sets for high performance requirements mainly, right? So, and but what the thing is, fine tuning is very costly process, and once you fine tune the model, you have to, you are just going through another phase of training. Once the training has been done, the model has been trained, and you are going into another phase of training for fine tuning the model. So you have to keep updating again and again if some new information is added or if some changes is made. So that is what fine tuning is, and that is why fine tuning is not performed much. It is done but not performed much because it is very expensive. It is having like it's very time consuming, and also one thing I told you is it is difficult to update frequently. Okay, so I have told you two ways. First is the RAG, which is retrieval augmented model, sorry, retrieval augmented generation, RAG, and I have told you fine tuning. These are the way you can make your model smarter. Model, your generalist model is becoming more, fine tuned, fine trained on some specialized data set. That is what is happening here. Are you guys ready to know how is RAG working? Like how is the model able to fetch things and how the process of answering is going on? Okay, so guys, RAG pipeline has two stages. First is the retrieval stage and second is the generation stage. Why I am calling this a pipeline? Because in computer science, in programming, when there are a series of steps being followed, when the data is going through each step, it is called a pipeline. Okay, so that is why I'm calling a RAG pipeline, because I'm going to write series of functions which my data is going through, and at last it will be out from the pipeline in the form of something which the model replies. Okay, so first stage would be retrieval and the second will be generation. Let me explain you from this diagram. So what will happen is in this RAG pipeline, you will get a document. This is the document your model will refer from. Right, the model is pre-trained and it already knows English, it already knows how to make sentences, words, and all these things. It has been pre-trained to do that. And you are training it additionally on your document. So this is your document. It can be in any form, PDFs, Excel sheets, any form. Okay, and this document will contain information that you want your model to train on. First of all, this document will get converted into smaller parts, and like we call them chunks. Okay, so first the document gets divided into smaller chunks, and then these chunks goes through embedding model. What this embedding model do? It converts these chunks into vectors. These are text. Text gets converted into vector. This is what embedding means. An embedding model, because we are already having a model by Gemini, by Google, who is embedding these texts for us, and we are going to use it directly in our code today. So after my chunks goes through this, they get converted into vectors, right? Numbers. And now these vectors will get stored in some database. This is the first thing which is going to happen with our documents. Fine. Now, once the user gives a query to the model to solve, okay, now what will happen? First of all, the user's prompt will also get converted into vector. And both the things, both the context from the database, which has come from the document, and the user's prompt, both will go inside this LLM now. Okay, we have the context part which is from the database and which is coming from the document we have provided it, and from the user we have the query. Both will go inside the model, and this model will understand, like, okay, this is the context I have to think from, and this is the user's question, and it will frame a reply and reply to the user. Now guys, the thing is, you will think that how will we know that which context will match this user's query, right? We have like many text, like many sentences stored. Let's say this is a document about smarted website. So it has many questions and answers stored, like smarted is a platform that has a lot of courses. Then some text will say something about the data science course. If the user is asking about the data science course, then the model should reply me the data science course only. So how will it know what the user is saying? So here the concept of cosine similarity comes in. Cosine similarity helps us to form similarity between what the user is saying and which text in my document is related with what the user is saying. Okay, so it measures the similarity between two non-zero vectors by calculating the cosine of angle between them. And what are these two non-zero vectors? One is the text from the document, line from the document, and the other vector is the user prompt. I just a second. So I have to check which sentence in my document matches with the user's query. How will I check it? I will take each and every line of text from my document. Let's say I'm having a document to show you guys. Let's say let's say this is your document. Okay, this is your document which you are giving to the model, and it contains 3 lines. So first of all these 3 lines are going to convert into vector. And this cosine similarity function will compare which line is similar to the question user has asked. And how it will do it is it will convert each and every line of text inside the document in form of a vector. Okay, in form of vector. And it will plot the graph between the user prompt and the vector, and whichever line's vector is closer to the user prompt is having less angle between the user prompt and that text, that both things are similar, those things will be similar. Are you guys getting what I'm saying? Are you guys able to understand? Just write yes. If you guys want, I will repeat it again. Once again, can you explain? Sure. So look, what should I explain, this cosine similarity or the whole rack pipeline? Spidey X, can you tell me? Okay. What should I repeat? The cosine similarity or the pipeline completely? Can you guys tell me what should I repeat? Pipeline completely. Okay, let me do that. I think the browser has stopped responding. Just wait for a second. I hope the stream doesn't closes. Okay, so okay, don't know what happened. So yeah, we have the pipeline here. So what is going to happen is I am going to train my base model and I'm going to make it a specialist model on some particular data. Let's say I'm having a website called Smarted and the model is trained to recognize the general data. It has been trained to answer general queries and not query regarding my internal database, right? It doesn't know about Smarted a lot. But I use the RAG, if I use the RAG pipeline, I can train my model and make it a specialist to answer questions related to the Smarted website. So for doing that, I have to follow a series of steps. First, I have to take a document which contains the data about my Smarted website. And this data can be PDF, can be anything. Okay, any form of document I will take. I will convert it into small pieces because this document can be like of 50 to 100 pages, right? I can have a lot of data about Smarted website. So first I'm going to break into chunks, then I'm going to convert individual chunks into vectors. What are vectors? Vectors just represent text in form of numbers. Okay, and how I'm going to convert these text into numbers? With the help of my embedding model. Once I have these numbers, I will store it inside some database. Fine. Now, when the user will ask some query to the model, it will not just reply to the user based on what it has been trained on. The model will go and like take the context from the database. Not the model will go and take the context from the database and the user query. Both will be passed to this model, and this model will understand the context from what is being passed from the database. And how will I judge which user prompt will match the text in my database? Which text is the answer to the user's query? How will I know this? Right? So, for knowing that, I'm using the cosine similarity. This cosine similarity will tell how much similar the prompt user is saying and what is written in the database is. So, for example, I'm saying what is smarted. So, for what is smarted, for user prompt what is smarted, the text smarted is an online platform will be closer, right? Will be similar. And hence these both vectors will lie closer in my graph. The angle between them will be less. So I hope you got it now what this RAG pipeline is and what is this cosine similarity. And now, guys, what will be able to judge by this angle? So, we cannot judge anything from the angle, right? So we need to convert it into some numbers. Will it make sense if I come and say to you that the user prompt and the text in your document is 17 degrees related or 24 degrees related? Will it make sense? No. So I have to convert it into a number, into a standardized number, and that will be done with the help of cosine function. This is the function, and the angle will be passed in the function. A and B are vectors. I hope you guys are getting it. Okay, okay. So let us come to the programming part now. The rack pipeline is clear, and we are going to implement this rack pipeline completely. So let me make a new file. You guys can do along. I'm going to make a file called rag.py. Just open your code editor and let's start the coding part. We will start by making some imports. So we will start by making some imports. Let us import OS, which is the which is I told you is the operating system, Python's environment. Import numpy as np. You will know why all these things are being imported and where they are going to be used. Just import them for now from Google, not GenAI, from Google. Import GenAI, and from .env import the function load.env, and at last from sklearn.matrix import, sorry, pairwise sklearn.matrix.pairwise, I think, yeah, import cosine similarity. This is the things you have to import to install the libraries. I think you should be having this GenAI. If you are like GenAI and load env, you must be having, because we did the code yesterday as well and we installed these libraries there. For your numpy, just write pip install numpy. For sklearn, just write sklearn, sorry, scikit-learn. Sklearn, you write scikit-learn, and it will install the libraries. Just write the name. If you guys are not sure about the commands, just search for them. Install sklearn in Python and you guys will get them. Pip install scikit-learn. Okay, just install them. I think, yeah. Now let us just load the API key as well. So what we did yesterday, we are doing the same thing, guys. We are just loading the key here. How we did yesterday, you remember? We just called this, right? We just started by making a client, and with the client we sent our API key. That is what we are going to do today as well. Is it rack.py? Just make it Now, once you guys are having everything set up, the next thing which we will do is what we saw in the rack pipeline was we should have a document to train my model on, right? To train my model, I need some context so that my model can learn from it. So I'm having documents which I'm going to give as context. So, guys, this is just a simple like text document, nothing else. It is not even a document. Just I have written some text inside an array, right? Nothing else. I'm not taking a complex document here because with complex document, you have to do all the steps like break into chunks and then, like you have to call the chunking model as well and do some other things as well. I just want you to know the rack pipeline. So we are not going into the complexity of it. For now, we are understanding what the steps are. If you guys want, I will tell you the exact pipeline tomorrow for like by making it for smarted website, and we are going to take the document, extract it from the web, the web only. We are not going to explicitly mention anything. We are going to take it from smarted.in. So I hope you guys are getting it. Now, the next step is to break this document down, right? But I don't have to do it because I have a very simple document. So let us just convert it into vector embeddings. Look in the diagram, we are not breaking it into chunks, just directly converting into vector embeddings. And for doing that, we should make a function, right? We are going to make a function for it. And let me show you how you can make a function for it. Define a function called embed text. And this function will take in any text and is going to embed it. I'm not making it particularly for this document only, guys. Look, I'm not passing the document here because I'm making it as a general function. I will use it again for embedding my query as well, which the user is going to say. So I'm making a generalized function here. I'm passing the text respond is equal to client dot models dot embed content. I hope, yeah, content. So I told you guys yesterday, today also we are going to use the predefined function which is available in the software development kit, right? So this is a predefined function that will be used for embedding, that will be used for embedding. So what is the model I'm going to use for embedding? The model is going to be models dot embedding 001. How do I know the syntax? Like this function will take two parameters. How do I know that? Because I have referred the official documentation which I provided you guys, and you guys can do the same. I have made the part easier for you. You don't need to actually refer it, but if you want, you can see it as well. I have passed two parameters to my embedding model. First, what the model is, and then the context, which is going to be whatever text is going to come inside. Just go till here. And after whatever text has been passed, has been embedded by my model, I'm just going to return it. So return resp dot embeddings and 0. I'm going to explain you. Let me just write it, or I should copy it for saving your time as well. Let me just copy it. So we have this. Let me explain you what this line will do. So as we have now made the vector embeddings, I am going to return it, right? I have to return it. Whatever my function has made, I have to return it. But for returning it, I have to go inside many boxes because the model does not returns a pure output. It does not returns the embeddings in numerical form. So what I have to do is I have to go box inside box. So first I'm going resp.embeddings. Okay, so it will give me something like this, a list containing an object, something like this. Then I'm going inside, I am calling 0th index of the embeddings. This will give me the first object in the list. And then I'm calling the values, which will actually give me the values. Okay, guys, so thing is, the model does not generate pure embeddings. It is very impure. And I have to go inside and inside to generate, to get my embeddings. So first of all, I'm going inside the embeddings, which will return me the particular embedding part, like you saw here, like this part, this particular part. Okay, the first object in the list. This will give me the first object in the list, and the values will give me the proper values of embeddings. This is no more an object now. So why am I doing this, like going inside and inside, is this model will not return a single embedding for each line. So for the same line, Smarter is an edtech platform that provides online course. This model will return 2 3 embeddings. Why it does that? Because it is programmed to do that. And for getting a single embedding of a line, we are just fetching the first index, right? I hope you guys are understanding. For each line, we are having multiple embeddings. And for extracting the first one, I'm just passing the 0th index. Just write it till here. Now, after converting our embeddings, what I told you guys, like after converting the embeddings, we were going to store it inside some database, right? But as this is not a lengthy text document, what I'm going to do is I'm going to make a simple list to store the value of embeddings, right? Instead of a database, I'm making a list to store my embeddings. So let me just copy it for you so that I will be quick. S- So this is the list, and I'm making a list for storing the vector embeddings. I hope it is clear now. Embedding is the numerical representation of text. So for each text this document is having, I'm going to convert it into numbers to store it. And after the embedding part, after embedding, the vectors will be stored inside a database. But here, since my document is not that big, I'm going to store it inside a list only. So I hope it is clear. I hope it is clear, guys. The next thing which comes here is seeing how similar is the vector embedding and what the user asking is. So I have to make a function for that. So I have to make a function for that. And for making a function, you have to write this particular code. Let me just explain it to you here. This is the particular function which we are going to make to compare if the vector embedding stored in my document for each line of text is similar to what the user is asking. For doing that, first of all, I am going to pass the user query inside the embed text function which I have written here. I am turning the user text into vectors as well, right? Because I have to check the cosine similarity. So I need two vectors. So I have converted it into vectors and I'm calling the cosine similarity function here and comparing both these things. QVec is what I have created here. This is embedded form of the user's query and DV is what I'm making here because I'm making a variable here each because I'm comparing the user query to each and every thing stored inside the doc embeddings for each and every text stored inside the doc embedding, not text value, that vector. Okay. So I have two vectors, one is this and one is this. Now why this 0, 0? Because this will return a 2D array which I don't want. I want a single floating point value. That is why I have written this here. And when this value will be computed, it will get stored inside the sims function. Sims value. Okay, it will get stored inside the sims in the form of list. What this list will contain is clear, I think. This list will contain something like a list of scores. Let's say the relation between the first text and the models and the user prompt is 0.89. So you guys are able to see it is very much related. What the user has typed and what the text in the document is very much related. And this is also the third text which is inside the document and what the user is saying is also very related. So the sims is storing values like this, the relation between the user's text and the doc's embeddings. Now, since we have the list of similarity inside here, I am going to sort this similarity. How I'm going to do that? I'm going to call the argsort function. And this argsort function will not just, sort it in this form. It will not sort in the form of similarity. It will not arrange the values like 0.32 first, 0.89 and 0.95. No, it is actually sorting in the form of index. It is looking like 0.89 is the 0th index. Okay, 0.32 is the first index and 0.95 is the second index. I hope you guys are getting what I mean by index. Index means the index of the text in the document. So after this, after comparing that this index belongs to this, similarity belongs to this index, this belongs to this. It will output a list like this: 102. 1 is for 0.89. Sorry, it will sort and return, right? 1 is for which? 0.32. 2 is for 0.95 and 0 is for 0.89. So it has sorted and returned me the index. But guys, I don't want my index to be sorted in ascending order. I want it in decreasing order. So I am reversing whatever the result here is returned, and I am passing k. What is the meaning of k? It is, just seeing the first. Here k is 1. So it is just picking out the first similarity, whatever the first highly related similarity is. Okay, so the first index, that's it. And it is going inside the top index. This top index will now contain a list which is in decreasing order, and in decreasing order it is telling me how much the particular text in the document is related with user query. And finally, it is going to return the first, like here, whatever I'm passing, it will return. Okay, whatever the I is, it will go and search for that particular I, and it will return that particular text. That is what is happening here. Next, after this, I'll just make a chat loop, and let me explain you the chat loop here only. So what is happening in the chat loop, guys? After everything is done, I'm going to give the context to the model, right? After everything is done, after all this part is done, I have to do this part. I have to give the context from database. And what is the context? How did I got the context? I have just applied the cosine similarity to find the particular context the user is asking from. And the user query, whatever the user has given, I have to give it to my model. So let me just do that. So how I am doing that? First of all, I am just taking the user input and checking the user input. Is the user input exit? If it is exit, I have to end the model. Input function is for taking input from the user, and the user input is getting stored inside the query. Now, once I have this query, I have to pass it, right? I have to pass it inside the search function. After passing the same parameters as what we have in the search function, it will find the similarity between the text and the what? The whatever the how do I tell you this? It will just return me whatever the similar thing is. It is retrieving the best document. And finally, I will ask for my Gemini, and I'm going to pass the prompt in this form. What is the form? This is the form: context, question, and answer. So I have returned it. I have returned it here. I'm passing it in the form of context. Where this context is coming from, it is coming from here. And I'm passing the question to the model, and the answer it will return me back. And yesterday's function I'm using, which is just generating the context for me. The model is generating the context for me. I'm using the flash model, and for the contents, I'm using the prompt. This is the prompt, okay? And at last, I'm printing out the response which is given by the model. And this is all in loop, so it will repeat again and again. Query.strip.lower is equal to exit. Yes, you can do that as well. Strip.lower, it's fine. Yes, it will be more better. It will be better because whatever the user will type will be accepted. And if the user mistakenly gives a backspace or something, it will work fine. So now when you will run this, you guys will get an output like this. Okay, smarter chatbot. And when you will ask it questions related to what I have provided, what is smarted, and it is telling me based on provided text, smarted is company founded with the goal of making education accessible and affordable. So guys, this is what rack pipeline did. I hope you guys got a clear overview of the rack pipeline. We took documents, we embedded these documents, then we stored the embeddings inside a list, and we found what is matching inside our list with the user input. And then we passed both the things, the user input and what was matching from the documents to this model to generate output in this format. And I have given it everything in form of a prompt. I hope it is clear. Just write yes, and if there's any doubt, just ask. And you guys just think of the doubts if you're having any, and let me pass the attendance form till then. Let me copy the attendance form. Yes, I am copying the attendance form out. Just a second. Okay. Thank you so much. Attendance, I'm passing the form. Just a second. No, don't write here. Bharat, I'm passing the form. Just a second. Day 5 attendance. And don't forget to write the review, guys. Like, how was today's class and what should I improve next? Just write the review and also fill the attendance form. You guys have to do both the things, then only this attendance will get evaluated. Yesterday my attendance form not submitted. They gave review. Can you consider that? The thing is, you have to do both the things, Prabha. You have to do both the things. Fill the attendance form as well as write the review. It did not got submitted. Was there any technical issue? If yes, just message me on LinkedIn and I'll help you out there. Do you guys want to see the code again? Is there any doubt? Please ask. Just ask me, guys, if there's any doubt. You understood the rack pipeline completely? Tomorrow, let us make it for smarted website, okay? Let us shape our LLM model for smarted website. And day after tomorrow, which is the last class of this 7-day boot camp, I am going to tell you how you can harness the power of existing chatbots, like some kind of prompt engineering and some things related to that. Done? Okay, guys. No doubts for today's class? Everything's clear? Review link. Let me just copy that. Okay, my screen is not being shared. I thought it was. Is no. Okay. I have shared the link for the feedback form as well. You guys can check that out. I'm not pinning it, but I hope you guys will be able to find it. The chat is already very slow. Everything's done? No doubts? Okay, guys. So you guys can also have dinner now. If there's no doubt, let's just end today's class and let us meet tomorrow at the same time. No, ma'am. What is no doubts? Okay, okay. Okay, guys. I will see you in the next class. Thank you so much. Have a great night.